I'm Dr. Sian Proctor, and I'm an analog astronaut.
I'm Jeffrey Notkin, President of the National Space Society, and this is
A Day
experience with our viewers around the world.
Well, I basically have space in my blood, I think, because I remember at an early age just looking up and just dreaming.
Our viewers around the world.
Well, I basically have space in my blood, I think, because I remember at an early age just looking up and just dreaming about going out there and exploring. And so I wanted to become a pilot, wanted to be an astronaut, all of these things. And it just so happens that in 2009, I applied for the NASA astronaut selection process, and I was a finalist. So I got down to a yes-no phone call, and even though it was a no, I became an analog astronaut over the last 10 years.
One of the things that really amazes me is that you tell this story about not quite being selected as an astronaut with
For feeding me.
And the director of the High Seas project, if I'm not mistaken, is Hank Rogers, who sits on our board of governors of the National Space Society. Colleague of yours?
That is correct. Hank Rogers owns the High Seas,
which is set in the world of comic books, which was filmed in Tucson. And I like to mix my interests, but somehow it all on the other side. And then there's the survival argument, which is we all appreciate that at some point in the distant future, there will be no more Earth. And so we do have to establish other living opportunities off-world. But there's a more nuts and bolts and more relevant and concrete argument for the day-to-day world. For that person who says, well, I don't understand why we're spending all this money on spaceflight when we still have problems at home. And the argument, the reasoning that we need to convey to that person is that every dollar that's invested in space development, in space technology, gets repaid back here on Earth to an enormous degree. Perhaps as high as 15 to 1 is one of the estimates. How do you feel about that? Is that a valid argument, a valid reason?
It absolutely is. I mean, we have real challenges here on Earth, and the way we're going to solve the International Space Shuttle or in a habitat on the Moon or Mars, then maybe we could do it on Starship Earth.
No, that's a good argument and a good hope. For me, I think it's arts-based, which might sound surprising since I'm a science guy, but I'm also an artist, and asks, so what will it be like when we send professional, experienced artists into space to share what they see and what they feel with the world at large? What will it be like when we have a great writer go into space to record the experience, or photographer, composer, or filmmakers? That's what I want to see.
It'll be amazing. The inspiration that will come from that. I mean, science and the imagination. To me,
Development at off-world, which means he's working on the space portal at NASA Ames. Pretty exciting stuff. And he is a recipient of NASA's Exceptional Public Service Medal. So, ladies and gentlemen, I invite you to meet Bruce Pittman.
Hello. It's just around the corner that we think will delight and amaze you. So the National Space Society was actually born from two predecessor organizations. I'd like to give you a little bit of history because it gives you a better perspective on the organization today. Dr. Wernher von Braun, who was the father of the Saturn V rocket and the former director of the Marshall Space Flight Center in Huntsville, Alabama, founded the National Space Institute. You'll see that he was inspired by the Apollo 11 program and the landing on the moon in 1969. So he decided to make use of the excitement around the Apollo program to provide homework assignments for his freshman's physics class. And so we started having them do a number of homework exercises. This summer study consisted of 19 faculty members from universities all across the country, 6 graduate students, and a number of NASA advisors. One of those participants, faculty members, was one of my undergraduate professors, Dr. Mont Hubbard from UC Davis. And the following year, when I was a senior at Davis, Dr. Hubbard explained what had happened in the summer study, and I got quite excited about that. So that was my first leverage off of work that had been done by Dr. Peter Glaser a few years before, and the idea of space solar power satellites, where you would have the colonists construct these large, huge, actually, space solar power satellites, again constructed mostly from material that was harvested from the moon, and then they would assemble, taking the theme of both of the organizations, both of the benefits of space and people living and working in space. The National Space Society adopted a vision, and the vision is simple and to the point. It's people living and working in thriving communities beyond the Earth and using the vast resources of space for the dramatic betterment of humanity. So you can see the blending of the two organizations, the National Space Institute and the L5. Fortunately, because of the pandemic this year, we were not able to hold our International Space Development Conference, but hopefully next year, if things get better, we'll be able to hold that, and we hope you can join us next May in Los Angeles. At these conferences, we give out a number of major awards. We are also getting more into social media, and so we are now have a social media campaign on Twitter, Facebook, and YouTube, and we hope you'll follow us on these mediums. Advocate. So some of the things that we've supported over the years and we continue to support is the International Space Station and the transition to whatever comes after, and that transition be seamless, that reducing the cost of getting to space and expanding the access to space for more and more people is one of our goals. Protecting the Earth from asteroids and cometary collisions, and making space travel safer, worrying about issues such as orbital debris and space travel. We have an award-winning. So what about this LEO economy? So as most of you know, we have an International Space Station that's been in orbit for over 20 years and permanently occupied in particular semiconductor and exotic glasses are some of the really exciting research areas. A lot of work being done in biotechnology and drug development and drug delivery, in regenerative medicine, including replacement organs such as heart, lung, kidneys, and even retinas for curing blindness. Food production and remote sensing are also some areas that are being researched on the International Space Station. As of last year, you've probably heard of, but may not know the details of what they're doing as far as space is concerned. The first is Elon Musk, who founded SpaceX in 2002 to make humanity a multiplanetary species. Over the last 18 years, I think it's fair to say that SpaceX has revolutionized how the Dragon and the Falcon 9 development was done as part of a public-private partnership between NASA and SpaceX. So the government paid a good portion of this, but SpaceX paid for part of this as well. And so as part of that deal, they were able to streamline the amount of oversight that NASA would do and give SpaceX some more design flexibility about how they built and operated the vehicles, but all within NASA safety guidelines. But they also, SpaceX owns and operates these vehicles. They are not owned by NASA. So now SpaceX can offer these vehicles to other non-NASA sources, and NASA is encouraging them to. Starship that Elon is building will be even larger and will have twice the thrust that the Saturn V did, over 15 million pounds of thrust. It will be capable of carrying hundreds of people to low Earth orbit, or 100 to 150 tons of payload. He already has a paying customer who is signed up to fly the Starship around the moon in 2023, and NASA recently awarded SpaceX a contract to develop the Starship around the moon in 2023, and NASA recently awarded SpaceX a contract to develop the Starship for landing on the moon as early as 2024. So the other person I wanted to talk about was Jeff Bezos and his company Blue Origin. Jeff was only 5 years old when on Wall Street in the early 90s, and he was very successful there. He was the senior vice president of a hedge fund in New York, but he gave it all up because he realized if he wanted his vision of space to come true, he needed to make some really big money, more than you could make even at a hedge fund. And so he quit his job there, and he got in the car, drove to Washington State, and founded Amazon. The rest is history. He is now the richest man in the world, and he admits that it was because of the influence of reading The High Frontier and the dream of next year. By the way, this was the launch pad that I launched, the first mission that I was part of, Pioneer Venus, back in 1978. So it's kind of interesting to see him making use of my old launch pad. So Blue Origin has teamed up with Lockheed Martin, Northrop Grumman, and they have also won an award from NASA to compete for delivering NASA astronauts to the lunar surface as part of the Human Landing System program that NASA has sped up. So what does all this add up to? So Musk's goal right now is to build a huge fleet of 1,000 starships over the next decade. And for all of the volunteers who have worked so hard to put together a day in space, we hope you enjoy it, and we welcome your feedback and support. If you are not already a member, we would encourage you to consider joining and participating with us in this exciting journey into the future. Enjoy.
Hola, beyond will be a better place for all of us.
Thank you, Bruce. I feel that your message really helps clarify the goals of this entire Day in Space broadcast, which is to highlight the excitement and the importance and the meaning of spaceflight, past, present, and future. And so it is quite appropriate that we are going to commence with a look back at
Space were built off of ICBM technology. And so when my dad was really young, he actually started working for NASA on Guam. And I have this, which is a commemoration of the Apollo 11. So 1966 to 1970, my family was on Guam. Have you been there?
Alas, no, it's actually one of the few places I've not been to, so let me put that on the to-do list.
Well, I was born...
Really fabricated during the Apollo era. You are a true child of Apollo. And you will appreciate this. I have visited 2 of the very remote tracking stations that were used in the Apollo missions. One was on Grand Turk in the Turks and Caicos Islands, and another is Parkes, the famous Australian observatory in the Australian outback.
I've been to Parkes.
Have you really?
I have.
Look, we just keep discovering all these things that we have in common. I did not know that about you.
My brother lives in Australia. All the help, Neil Armstrong, Apollo 11. My older brother Langley, who lives in Australia, has that. But I have this, which is the commemorative plaque, and it has my dad's name on it, Edward Langley Proctor Jr.
And doesn't that speak so admirably of Neil that he would take the time to travel around the world and thank people?
Oh, yeah.
That's the first time this interview's ever aired. It's an exclusive sit-down that I did with him quite recently, talking about his extremely exciting life in space. And yeah, well, I suppose I have to own up and tell you my favorite Apollo mission. Although before I do that...
Can I guess?
Yeah, go ahead, you guess. Why don't you guess?
Well, I would say Apollo 11 because that's the one that most people would pick. But maybe Apollo 13?
Well, Apollo 13 would be a really good one, and we will be hearing from Fred Hayes soon, and of course we love the film. I have to say my favorite Apollo mission is Apollo 9. And I'm a bit of a contrary guy. I never like to pick the obvious. So here's why.
Cunningham from Apollo 7.
And Jerry Griffin, the NASA flight controller.
And what I love about this is that they're going to talk about the challenges of the Apollo program of going to the moon, not just once, but multiple times. And that's really relevant to right now because we are going back to the moon.
I'm just going to jump right in because we have a lot to cover and not a lot of time. So our topic today is innovation in the space race era and beyond. So in 1957, as many of you know, Sputnik was launched by the Soviet Union. It's their first satellite, little thing about the size of a basketball. Went into Earth orbit. All it did was beep and take some very rudimentary temperature measurements, but it scared the dickens out of the West, and people were just thinking, oh my God, the Russians are ahead of us, what are we going to do? You all remember this. It was a big moment, and the Western powers went nuts. Well, I think, and you would know this, there were probably a lot of slack jaws that afternoon when that announcement was made because we didn't really know how we were going to get there. Some things we didn't even know what we needed to know to start to how to get there. Questions in metallurgy, questions in rocket engine design. All this stuff was brand new. Looping the moon, they could probably do that first, but landing on the moon and coming safely home was complex enough that we had a good chance, and as it turned out, that worked out to be the case. We managed to do it. So I think if you look at that era and you look at Kennedy's speech, there were two of them, one to Congress and one to the public, and you really listen to what's being said, there's a number of things, and Tony writes about this quite a bit in his book and the articles he does in a magazine I edit. This program that he laid out to land on the moon by the end of the decade was a clear goal, it was a concise goal, it was bold and daring, it was competitive, which seems to be something that Americans like, it was well-funded, which is important, but perhaps most importantly, it was time limited. So I'd like to ask you gentlemen, you were there, all I do is write about it. You were there. What parts of these factors do you think were the most important that made this achievable in that period?
But we had another advantage in that we were primarily pretty young people. In fact, I was one of the oldest guys in the control center because I'd served 4 years of active duty in the Air Force, and I was 29. And I was one of the old guys. We had guys 22, 23, right out of college. We've been told to do this. We've been given the keys to the car, essentially, and told we could drive it. And couldn't do it, so we just set about to get it done. And we had support from both sides of the aisle, Republican and Democrat. We went
the space program of any president we've had. But I think there's a lot more to him making that pronouncement than there was just a competition with the Russians. Back in the late 50s and early 60s, there was a lot of unrest in this country. We'd had the Bay of Pigs. We'd had a bunch of other things happen. And I think this was also an attempt on his part to bring the country together because it was a goal that everybody in the country understood and supported. And I think that was very important. But I think there's also a hidden component in all of that, which to me is the key to why the Apollo program was successful and why this country has been so successfully in the markets. That's important.
The only thing I'd add, at the time, career-wise, I was a test pilot for NASA. I was at Lewis Research Center in Cleveland, and then I moved on to Edwards, where the X-15 program was going on. And so my only knowledge or association anyway with space was rocket engine testing that was being done at Lewis. And of course the X-15 rocket ship was in play at this grassroots support we've had in the space program since. People could relate to that, and it was pretty spectacular to think about. And I think that was another thing that also, if they took surveys and whatever with the Politico pay attention to, I think it was doing pretty good even in that time frame for the most part, through part of the program to get to the moon. So I think that helped as well to keep this assurance.
First, I would like to thank having such Russians and them being ahead of us, if you will. And this may or may not be accepted by my friends who haven't heard me say this, but when we set out to go to even before we set out to go to the moon, when Alan Shepard got his flight, that was like a month after they had sent Yuri Gagarin up. And that Yuri Gagarin, he was up and around the world once. I guarantee you the Russians did not have control of that spacecraft. He's along for the ride. We had a different set of program going from the beginning. And as a matter of fact, since there was a delay between the Mercury program and the Apollo program, which was the program that was going to go to the moon, we filled. Technically, we had regained, and we're back, in my opinion, we're back in the first position for getting man into space and back.
I just want to make a little comment about how important Al Shepard's flight was. I was flying in a fighter squadron in Washington, D.C., out of Andrews Air Force Base, and all the pilots were kind of milling around the pilot's lounge, which is really our source of coffee. All from our aircraft maintenance officer, who's up test flying one of our F-102s, and he's having a problem with it, and he's got to come back in and make an emergency landing, and he can't get the gear down. So he's going to have to land without the landing gear on his airplane at the same time that Al Shepard's getting ready to take off. So we had a choice to make. Did we sit there and watch Al Shepard go, or did we get our marshmallows and go to the runway for Major Stenger when he was going to land his airplane? And you obviously know which ones we did. Yeah. We collected our marshmallows.
Requoted, it's almost as if they reached into the 21st century and brought Apollo back to the 1960s. So my question is, with that kind of innovation comes a certain amount of acceptance of risk. And I think that equation has changed over the years. I think NASA got very sensitive.
Accept almost any risk. I know as far as my crew was concerned, we decided amongst ourselves before we ever left the launch pad that we would accept dying on the flight because what we were doing was more important than we were. Now, I think there's a whole series of levels of goals and risk in between those two. So I think it's really a function of how important the goal is.
As it turned out, things might not go right. You considered that I had a designee, Jerry Carr, that I had to my house before I flew, that Jerry knew where important papers were. And he was the guy. I was on shuttle through the whole design phase, through the whole design development phase, participated in all design reviews, wrote RIDs, which are discrepancies on the design. So you were intimately involved in what this thing was going to look like and act like and how it was going to perform. Then you would test it. You tested in the vehicle, the hardware, throughout in the plant, in factories, and then when they were shipped to the Kennedy, special tests there that you were involved in. So you got a lot of confidence in the hardware. And most of the workers that were on the program throughout the U.S., and there were a lot of them, over 400,000 at peak of Apollo, that felt that way, that this was important enough and they were going to do the best they could to make sure everything was right.
I would say that the most obvious thing to me these days, this day and age, is how our public at large actually has changed. And back in those days, they can. And less than half of the people are military pilots. And you could be a military helicopter pilot today. So in my opinion, what made that really in the end a success was the attitude of the people that we had.
Fortunate to work with every astronaut from John Glenn all through Apollo, and then later when I came back to Johnson Space Center, I got to deal with a lot of shuttle people. There's one thing about astronauts that I learned in that 25 years, and that is I didn't think any of them were afraid of dying. They really weren't. What they were afraid of is making an error. Screw make one, it was going to be somebody else. The other thing is, I've been asked before, what was the real job of mission control and all of that structure that was on the ground. And it took me a while to get to it, but in my opinion, our biggest job was to manage risk. We were trying to manage risk to the lowest level we could. But you got to remember something. When you strap in to have to take a risk to get something done. So that's kind of the 20,000-foot view, I think, of what it's like to undertake something like going and landing on the moon. Two really dynamic phases. One is Earth orbit, getting out of it. It's fairly easy comparative to that until you get to the moon, and then you got to land. And so you got these two dynamic phases at the end. We're going to face the same thing going back to the moon. We're going to face the same thing going on to Mars and beyond. I agree that that's just another step. But you need to think about the risk. It is a risky business, much, not too different, but a little.
A hatch malfunction, and they were exposed to a vacuum. The United States and Russia at the time were sort of looking at each other and not very friendly. But the space program immediately called us and told us that they had a problem and that they would keep us aware of what they were finding out with that problem, what caused the accident. And as a result of what the Russians told us, we changed the procedures on our flight to always wear a spacesuit if there was a possibility of opening a hatch anywhere. And that was based on what the Russians told us, even though our countries were in conflict at the time.
You four guys, this question, do I need to get closer to this? Because you have a knowledge base that is really unique, an experience base really unique. Where is the sweet spot for
In the 1960s, I think we're talking about $140 billion, $150 billion. So the costs are high. So you got to be willing to do that. Not to mention the fact that our culture and our society changes every year too. It's increasing tremendously. So we spend a lot more money on a lot of other things that keeps us from having, you know, the money that we in those days we were willing to do to go to the moon. The Russians, they got to get back to it. We also have to continue to be realistic on how long it takes to get some of these places today, because we have folks, especially the private industry out there today, trying to sell on a basis that doesn't even come close to being sensible.
To the moon back and forth. The real exploration is done after you get to the surface, be it on the moon or on Mars. So any part of that architecture that the commercial guys could fill, say getting a low Earth orbit with either people and supplies, clearly NASA's not meant to be a truck driver to haul stuff up and down the low Earth orbit. That's not exploration. So if the commercial guys economically fit into that, I think surely that's what you use and take it.
Government. Boeing doing the same thing with their spacecraft. They're getting funded by the government. Jeff Bezos is the only one who's putting his own money where his mouth is. And I think we have to be careful when we talk about private industry doing these kinds of things, because I don't see any difference between SpaceX and North American Rockwell 40 years ago.
After the shuttle.
You think he could have done it if they hadn't stepped in?
I don't know. But
well, he did raise $100 million also of private investors.
He's got some investors.
Yeah.
It's not the thing about Jeff is that Jeff's own money. I mean, it's out of his pocket. And I heard him say 2 years what I think. I think the commercial guys have shown enough zeal and enough expertise, frankly, that I think they're going to own, as much as what Fred is saying, they're going to own the domain of low Earth orbit. And they probably should. It's a hauling job. And that leaves NASA then to really get back to exploration, looking down the line. But remember, when NASA puts out money to go back to the moon or to Gateway or to Mars, whatever they're going to do, they're going to buy it from American industry.
Do it, and you need that to do it, to go to those new places.
The worst thing about the Mars mission is that we got a lot of problems that we haven't solved yet to get there. You're going into convulsions and more like an atomic nuclear weapon might do to you. It's that it ups the cancer risk. You probably make it back okay, but then in the next few years you'll probably see a deterioration. So it's a interesting.
9 years old. And I'm just thinking about a 1.5-year flight in a small spacecraft, size of a Volkswagen Beetle, and you got 3 people sitting there, and if they're all 29, I guarantee you, before too long, somebody's going to be getting some pretty bright ideas about something, right? But I say, hey, I've lived a great life. I can go any day, and no mistake about it. It would be great.
So I can see a great branding deal between SpaceX and Barco Lounger now with you guys in there and your remotes going,
Well, Al,
I can't get NFL today.
Al, I have to tell you that what they can do then is they can get control of the CO2 that we put out. So, and if they do that fast enough, we can go to Mars so we can survive.
Okay, guys, it's nap time on the spacecraft, right? So, just to steer back to innovation for a moment, we do seem as a country to innovate very well under pressure on a timeline and with a certain amount of competition, whether it's internal or external, which brings me to the question of China.
Through the aerospace medicine side of things that I won't get into, but right now we are not allowed to work with the Chinese. It is a restriction placed by the Congress. We can't do it. We're making some breakthroughs through the aerospace medicine side.
The program manager for the space station that they're going to put up in 2023. I was invited to their space center, but 10 days before we were to go, the U.S. State Department called the guy that I work with and said, you can't go. And I'm confused about that because I could never figure out, and I think that's the thing, that's the glue that holds a lot of these space programs together. And I'll tell you, the Chinese are no slouch. I am firmly convinced they're doing stuff that maybe we can't even do right now because we've not planned for it. But they're very, very good at what they do, and they're very far thinking, which we are not. And I think that's going to be a big, big plus for the Chinese in the long run because they plan way ahead and we plan a little ahead.
They landed.
So in that role, I had to work obviously closely with ESA for their Columbia module, with the JEM, the Japanese experiment module, Japanese people. Mitsubishi Heavy was mainly who I interfaced with. And of course Canada with the second arm they built, robotic. STP, for a while they were passing written notes back and forth rather than open communication to talk about issues. And you can't operate that way. So it has to be beyond the governments involved to say, okay, we condone that this group is now going to go off and take on this task.
And wavelength for all of these jobs to do it. And there's still kind of competition that goes on to try to make your country look good when you do it. Frankly, I think that the next time that somebody lands on the moon, I think it's probably going to be the Chinese on doing that. Keep in mind, that's been a long time, and nobody else has been to the moon than us in 50 years.
I think we ought to be cheering the Russians or the Chinese doing and maybe help us along with our own program. I think the Chinese, they've got some fantastic engineers working for them, and you know why they're fantastic? We've trained them. They've all gone to school here in this country, and they all have to go back to China when they finish with their school. They can't stay here. So, in fact, I gave out a scholarship to the University of Michigan. I was telling some people the other day. I gave out a scholarship to a math student to the University of Michigan. There were 100 people in the auditorium, got through with all that, took questions and answers, and the question was,
Well, I feel like I'm just getting started, but I think we're pretty close to our time limit. So I just wanted to close with a quote. Years ago I had, so let's dare again. Thank you very much, gentlemen. Really appreciate it.
How's it going, everybody? My name is Ron Sparkman, and I'm the Chief Curiosity Correspondent for the Space Foundation Discovery Center and the CEO and founder of Stardom. Space exploration is important to me because it quite literally changed the course of my life. Understanding the cosmos and seeing what humans are capable of when they put their minds to it highlights the epitome of the human spirit.
Thank you to the Apollo astronauts for sharing your story with us. And it makes me think about when we go back to the moon now and put the first female steps onto the lunar regolith, that iconic picture of Buzz Aldrin. We all know the one that I did multiple spacewalks. But what I like the most is that he actually has a doctorate from MIT. Did you know that?
I did know that. And it's just one of his many accomplishments. He was also a fighter pilot, an author, coined that phrase "magnificent desolation" that has been so widely used to describe the lunar surface, and has been a great ongoing vocal proponent for crewed spaceflight, and has developed the concept of the Aldrin cycler, which is a viable engineering-based plan for getting humans to Mars and back in an affordable and efficient manner. But I'd like to take the opportunity, if I may, to highlight a couple of Buzz's truly great accomplishments, which since I was a kid. So I was very fortunate to grow up with eccentric parents who thought that spaceflight was more important than school. So I was excused from going to school in the late 60s and early 70s. I got to stay home and watch the moon landings. Courtesy of a note from my quite imperious father to my quite drunk British headmaster saying young Jeffrey will be staying home to watch the moon landing. So I had this double bonus. I got to watch this live on our little black and white telly in South London, and I didn't have to go to school. So no wonder I've got such a positive association with spaceflight. By this, because I'd watched the moon landings. How does my dad know Buzz? Why does my dad have a watch from Buzz Aldrin? And my dad was a very mysterious guy. We actually think he was a spy. So he said, oh, I did some work for NASA in the 60s and 70s, and Buzz gave me that watch as a thank you. So I quizzed Buzz about this. He claimed to have no recollection of it, which is exactly the answer you would give if you had given a watch to a spy as a thank you. So there's the mystery. There's the mystery of Dad and the Buzz Aldrin watch will never be solved. My dad's passed away since.
Now I gotta look at my dad's watch and contact my brothers, because my older brother...
Right there in front of me with his team and other astronauts, so no pressure, right? You're delivering your keynote, and the great Buzz Aldrin sitting right there, looking perhaps slightly disapproving, or maybe it was just the spotlights. So Saturday, I sit down with him before the dinner with my very copious notes for what I think is going to be my brilliant introduction to Buzz. And I said, so Colonel Aldrin, is there anything you'd like me to particularly mention, or anything you don't want me to cover? And he goes, yeah, I just want you to make sure to keep it short, because I have a lot to get through. So I was a bit taken aback by that, and I said, oh, okay, certainly, Colonel. I'm glad you said that, because I'm a bit of a talker. And he looked at me and he goes, yeah, I know. I saw your speech last night. So I said, well, thank you very much, Colonel. And he goes, and here, wear this shirt. And he gave me this fantastic...
traveling very far and support local events, but there's a unity that ties them together. And at one time, of course, it wasn't the National Space Society. It was merged between the L5 Society. It's a continuity in particular places. We have a Space Society of Australia, and Kirby Eichen becomes a friend. I look him up when I visit Australia. Hugh Downs, the Board of Governors. He and I were at the North Pole together.
That's a good bonding experience, I imagine, the
Yeah.
North Pole.
And I went scuba diving with Werner von Braun.
Was he a good diver?
But I think NSS really has an appeal and should have a presence in most of the professional societies, at least in letting people know or getting them to help spread the word around to maybe the younger, but it's not just the younger, it's maybe the people who are trying to get recognition because they're
Every person can get involved with. How do we make this engagement in space attractive and easy for new people?
well, space is just a different way of doing things, of getting somewhere. You don't have to build railroad tracks. You don't have to go plowing through the mud or whatever. But you get into orbit and you get there. You stay there for a while. You better bring along some air and some food and some way to get back down. But that's what makes the space society. It's not a society of people who've been there particularly.
You may have noticed
Into it. But it can become quite wasteful when there's a competition. If you're interested in doing things jointly together, it's best to compete at the design level, pick the best design, then cooperate at the operational level where you carry out things.
so that way we get the brightest minds coming up with their own ideas. We pick the best one, and then we take the industry and the resources to make the best one.
With that one.
Can we manage that as people to actually pick what's best for us collectively? It's a noble aim. Do you think we can get there through international cooperation?
Well, when you get into that, an awful lot depends on who can pay the most, who has the talent to do these things, and that certainly comes into my crucial analysis right now. That we got 5 capable nations: the U.S., Europe, Russia, Japan, and China. In some order, and the order is that to not have a competition with China. I think we've already seen that with Russia we can work together, and there are ways that may not be too beneficial for them and for us, no matter whether they got good rocket engines or what. But to start off international relations with various political reasons why each one kind of wants to keep going, and it makes it difficult to discontinue unless you got a better idea, and unless whoever's going to lose, you got something better for you. And try and use a lander at the moon again. No, we would go to a different place. We use designs similar, but they come back and they land in the ocean, and they're not really quite so suitable. But you can segment the areas where it is appropriate to reuse something, is how you can get it to where you can make it readily available. And there's sometimes, just because we're doing it that way, that doesn't mean there might not be a better way of doing something. When I first started looking at Rendezvous, I wasn't at all satisfied that the people knew what in the world they were doing. But it was so simple and basic. Now, of course, being in one airplane and trying to catch another airplane, that gives you a little advantage in thinking about things. for various reasons, needed to come up with maybe better ways, maybe a freer society. I think in the Asian world, it has somewhat been predominated by, but you can bark up the wrong tree, and you can follow something doggedly, I'm gonna make this work no matter what, and then you find out it was not meant to be. And there are a lot of blind alleys in a new business like space, where mass, velocity, duration can see the big picture at all. And I don't know, I just feel I'm so fortunate to think that I have that. Now all I have to do is convince other people that I'm right.
It's a noble aim. So we're in an exciting time in spaceflight now. We have all these independent groups starting. We've got space tourism. We're so close. We're so close to asteroid mining. How do you feel about this enormous transformation of which the NSS has, in a sense, kept the dream alive to a degree all these years, and encouraged these small companies? And now we go to a thing like ISDC, and it's full of independent space.
People want to do something dangerous. Well, there's a thrill, but yeah, there's a hazard to it, and there's a notoriety. And after a while, people will adjust to that, look at the odds, and there's somebody who's going to want to walk the tightrope from one building to another. Or somebody is going to want to jump out of an airplane. Not me. If the engine's working, I want to stay in the airplane. So you find that there's just a big pool. Why not us? When the time is right. And a number of years ago, we were caught up with enthusiasm, and we'll get to Mars 1990 or something like that. Man, that passed us by so fast. And a lot depends on the national priorities and whether there are other diversions and the leadership. And it's troubling when there's such a dispute about the leadership, and it's regrettable that there's a revision with major administration changes. There really needs to be more of a continuity. To get back to tourism, there was an opportunity for the U.S. to build a crew return vehicle that would take people up and crew return, and it would leave them up there. Opportunities will come, and they'll be taken advantage of. And we've missed a good number, I think. But I think in the future, it will prove to be a diversion that was not quite worth the time and the effort to move in that direction, and then to have nothing kind of left over. And the original lifetime of it was 2016 and 2020, 2024, and now I freely hear 2028, and things are getting old. And they're not going to, and besides, you do something there, it means you can't do something somewhere else in a different way. And it's expensive. And we want to privatize it, it's too expensive. Except and once you put something there, it's there. You can't be moving it around. And I'm not sure that not bringing them all back, leaving one on the surface, and the only thing that returns is the capsule that the crew's in. well, we're learning how to do things quite a bit different, and I don't think we've reached the limit at all. I mean, I look at we've got something that has to adjust to the surface of the moon from orbit. Well, that's a lander, and what's in between kind of goes from space to space. And try and make one do the other or do all may not be resources that we don't have on Earth. They're going to be very valuable. Now, how much we can use the lower gravity, the absence of an atmosphere to our advantage on the moon, I think we're going to find that out. It's not a place where when you go there, 7 months again, 2 guys for 1 day. And we got a little bowl, we put a little mobility in it. So at the end, when the Vietnam War and other things kind of ran us out of money, we had 6 out of 7 successful launch in 1 day. And we got a little bowl, we put a little mobility in it. So at the end, when the Vietnam War and other things kind of ran us out of money, we had 6 out of 7 successful launch and landing. We have a short time there. So that didn't last. But if you go at the best time on fuel, and you come back at the best time in fuel, you got about 1.5 years. And it's vacant for 6 months, 8 months, depending on how energetic. But that's a visit, and it's an economic visit. But you visit, you visit, you visit. That's not accumulating too much. Well, you can visit, stay there, and somebody else comes, but then you go back home. So everybody who goes comes back home to go there, paying for somebody to go here. Again, you don't have to bring them back. And each one that goes there knows what he's getting into right from the very beginning, and he either likes it or he doesn't like it. So there's a kind of a crew advantage. It's going to work the first time it gets there. And there are ways of assuring this. And now just look at the crew position, look at the cost, and look at the presidential commitment. It isn't going to happen until 2 more presidents, and they may chicken out by then. But and I think this is the kind of analysis that somebody has to go through and then say, oh, you're wrong, this isn't going to be important, or this isn't. But when the last time you flew in space very well, the most critical thing that we have to take into account from the very early stages, especially if we're going to talk about migrating. And that's better than a permanent settlement. Heck, you can visit for all these big decisions, and they don't want to be a part of stranding somebody somewhere else. That's his decision. That's the government's, that's the world's decision, to see whether there are people that fit into the expense.
Greetings from Island of the Gods, Bali, Indonesia. My name is Anna Camaro, and I'm the founder of Antrexa Space Global. I've been mesmerized by the vastness of the galaxy and how we're nothing but a speck of dust. I went to Baikonur to see the Soyuz rocket launch, and I believe that everyone should experience all these inspiring moments in their lives, so that we can increase the collective consciousness for humankind.
The Apollo panel. You know, Cyan, I won stage and Rick Armstrong, and I had them at my mercy for 90 whole minutes. And I spent a long time preparing questions that I thought and hoped they'd never been asked before. And the highlight of the panel for me was as follows. I said, gentlemen, I'm going to ask you a question, an unusual question. And when you hear this question, I don't want you to think about it. I want an instantaneous gut reaction. And if you feel the answer to this question is yes, I want you to just raise your right hand. And so the question was this. Gentlemen of Apollo, do you think, yes or no, that somewhere in the universe there is some form of life? And all but one instantly put their hands up. I'm not going to tell you which one it was who didn't put his hand up. So ladies and gentlemen, there you have it. 9 out of 10, Apollo.
And so I won't tell you whether I passed or not when it came
no
to...
pressure. Stephen Hawking asks if you're a genius. Yes
Right,
or no?
exactly. But the nice thing is that there are people out there that are actually looking for exoplanets, but not just exoplanets, but life on those planets. And one of those people is Dr. Sarah Seeger, and she is an astrophysicist and planetary scientist at MIT. And what she does is that she looks for biosignatures in the atmosphere of exoplanets. Mind blown.
In this gorgeous northern night, but I'm actually in my home with this background of the stars because I wanted to start by sharing with you or reminding you that every star is a sun. And if our sun has planets, Mercury, Venus, Earth, Mars, etc., surely those other stars should have planets also, and they do. But our galaxy, the Milky Way, has hundreds of billions of stars, and in our universe, there are hundreds of billions of galaxies. So the number of planets out there is just unbelievable, and we're hoping that some of them have life on it. We're hoping that some of the planets have life on them, and that the life breathes out gases that can accumulate in the atmosphere that someday we might be able to detect with our telescopes. Now, we'd only be able to detect planets and signs of life in their atmospheres around the very, very nearest stars. And all of that is what I'm going to tell you about today. So what I'm going to start with, not very big. Here it is while it was still being worked on in the clean room at Northrop Grumman. And you can see people there for size. And what you can see are the solar panels. Those are the most obvious thing out to the side. Those were deployed, stowed for launch, and they were deployed after launch. Antenna. And inside, you can see these 4 identical cameras. Well, you can't see them because they've got a cover on, and a giant baffle. In this image, it's a close-up, and you can see one of the test cameras. The actual aperture is not very big. It's only about 10 centimeters because these cameras actually are cooled to very cold temperatures. So this is an artist's conception and animation of the test mission in space. And these 4 cameras actually are aligned in a special way so that they cover a large strip of the sky. Each camera is about 24 by 24 degrees, if that means anything to you. And the cameras are made to tile the sky in, and how many of them tests might be able to find. So TESS is actually searching for planets by the transit technique. This is a very established, very mature method to find planets. You can see on the top is an artist's conception of a star, like our sun, with a planet going in front of it. And the bottom is actually showing you the so-called light curve. It's the star brightness as a function of time. So it's got about 27.4 day observing period per segment. And you can see that at the top, the segments overlap in this so-called continuous, it's not a continuous viewing zone, but it's like this overlapping zone. And there we can detect planets with much longer periods. Monitor the star brightness as a function of time, and to get a time series for all the stars that we can. And that would be 20,000 for every sector, every 1 month sector. That would be about 20,000 2-minute cadence, what we call postage stamp images, and about 1 million 30-minute cadence images. led to finding these planet candidates. We just call them planet candidates because a lot of work has to be done to actually determine whether a drop in brightness is due to a planet or something else. So once we have a planet candidate, we give it out to the community of astronomers, the test team and other people, and their goal is to follow up the planets, to look for other signs, to make sure to see if it's a planet or a binary star or another type of false positive. I'm only going to show you the tiniest amount of data because it's all we really have time to go through right now. So on the top here, what you're looking at is the star brightness as a function of time. And the time is listed in days. So it looks like it's about a month. So the drop in brightness actually is flagged for you in this case by the computer by the little triangles at the bottom of the top panel. So here the computer thinks it has seen two eclipsing each other, which is one of our most common false positives. In that case, it would be a more slow crossing because the stars eclipsing each other are very big as projected on each other, and it takes a lot longer for the transit to happen. For the flat bottom, same thing. The planet, if it's a planet, will be fully superimposed on the star while it's transiting. Whereas for a binary star, the stars will take a long time they'll never really flat bottom because as this one star eclipses the other, it's just taking. And remember, the blue triangle is what the computer thinks is a transit. Remember what you're looking for. Box shape, flat bottom, small drop. It's hard for you to tell what's a small drop. The flux is just what we call the brightness of the star, and it's in relative units because it's got this very V-shaped light curve, and what it means is we must have two very big objects that are eclipsing each other. If you look at the top plot, where the data is not phase folded yet, you can see that each transit, the odd and even transits match, but every other transit is a different shape, or a different drop in brightness rather. And that's because the two stars eclipsing each other are different sizes. Okay, this one is not this is actually two different ones. And the blue triangles again are where the computer thinks there's a transit. The one on top is some kind of eclipsing binary star. It's a very clean transit light curve. I hope you can admire it for a moment. This one is a sawtooth pattern. It's got to be some kind of variable star. Even though the computer thought there was a transit here, this is definitely not a transit. And in the bottom plot, again, you can see the red line is our best fit model. It's not fitting the data very well, is it? The red line hardly goes through any points. This one's definitely not a planet. What about this one? Now, most people I run these slides by who are not trained, at least you weren't trained, you only got a 1 minute. The bottom panel, you see again the phase folded plot, or the bin data. And there, it looks pretty nice actually. And if you thought this one was a planet, you were right. So I'm now going to walk through a few of Tessa's discoveries. The one we just looked at, this light curve, belongs to a planet called LHS 3844. This isn't, I'm showing you about 700 degrees Celsius. This planet actually likely has no atmosphere because the observers monitored the planet as it was orbiting the star, and they saw that the day side was the day side of the. They saw that one side of the planet was so hot, and the other side was incredibly cold. And for a planet to be very hot on one side and very cold on another, it likely means the planet has no atmosphere. Now, I forgot to mention that planets so close to the star, planets that have a very short period, that their orbit is only 11 hours, by Kepler's third law, they're also orbiting very close to the star. And these planets is not like Earth in any way, and for comparison, Earth is shown in the left, top left. But it's a really interesting system for a reason I want to explain to you. That the inner planet is what we think is a rocky planet, it's just about Earth size. And the outer two planets are what we call mini Neptunes. It's over 2 times the size of Earth, between 2 to, let's say, 4 times Earth's size. And why these are so interesting, incredibly common. They are likely the most common type of planet in our galaxy, yet there is no solar system counterpart to them. So it turns out that in our solar system, we have the terrestrial planets like Mercury, Venus, Earth, Mars, and we have the so-called giant planets like Jupiter, Saturn, Uranus, and Neptune. But we don't have anything 2 to 3 times the size of Earth. Now these common planets, we actually don't know what they're made of. We don't know how they formed. There's a lot of different theories about them. But one thing astronomers have found that might lead to clues to what these mini-Neptunes are is the so-called radius valley. If we count up high-energy particles, and that they actually have kind of been slowly evaporated with time, whereas the mini-Neptunes, they're typically a little farther away from the star and that they've managed to hold on most of what they were born with. So we actually think that if we have planets in the same system that span this, and the one we're most interested in is TOI 700d. And TOI 700d is a rocky planet, and it orbits in its star's so-called habitable zone, the zone around the star where the planet is heated to be not too hot, not too cold, but just right for life. That is an oversimplification, because we don't know anything about the planet's atmosphere. We don't know about its greenhouse gas power in the atmosphere. We have no idea what the surface temperature is. Nonetheless, it's really the distance of the actual star from Earth. The planets, this graph is actually showing you the planet radius as a function of the distance from our Earth in units of parsec. 1 parsec is about 3 light years. But what you can see here is that the test planets, which are yellow and orange, are relatively close to Earth, actually. Everything is still incredibly far away, but these planets are much closer than the blue ones, that are bright enough for follow-up observations. And we actually are all eagerly awaiting the launch of the James Webb Space Telescope. The James Webb Space Telescope is 6.5 meters in diameter, and it will operate at infrared wavelengths. And it will orbit very far away from Earth, where it's a quiet, very special environment for astronomy. And we sometimes call the test mission the finder scope for the James Webb, because it's finding all these interesting planets that we're going to follow up. It's not just the James Webb Space Telescope we have to look forward to, but we're also trying to we're also looking forward to other telescopes. For example, the 30-meter telescope and other extremely large ground-based telescopes. 30 meters is huge. Just want you to think about that for a moment, how big 30 meters is. And this, we can see planets directly. Starshade is a big ongoing prototype scale versions of the starshade, including the one in the middle that the person is touching. We call it membrane management, how we're going to still unfold all the material that we need to block out starlight and have the starshade be functional. Now, I want to tell you how we're going to study planet atmospheres to solve problems like about the mini-Neptune radius valley, and how we're going to ultimately search for signs of life on planets far away. Now, I'm confident that most of you have seen a rainbow. But what you might not know is that if you could look at the rainbow very closely, you would see pieces of the rainbow missing, some small colors missing. And these, I'm going to show you now a picture of our rainbow, and this is spectra of atmospheres far away, and to identify atoms and molecules in the atmosphere. And in fact, we already do this. We already actually do observe exoplanet atmospheres. Hot giant planets, mostly. Some mini-Neptunes, some cooler planets. We're not able to study objects like TOI 700d yet. So far, we can only look at really hot planets. It takes more effort to understand the physics and chemistry behind the code. So it's going to be a great future for us. So spectra are required to identify a planet as Earth-like in the future, using the large telescopes that I showed you. For example, Earth and Venus are about the same size and mass. Venus' artist's conception is showing you thousands of molecules in the background. Life on Earth actually produces so many molecules, thousands and thousands of different molecules. as byproducts of their metabolism. Even us humans, we're breathing out carbon dioxide. Cows and such release methane. There's ultimately lots of gases when you walk through a pine forest, all those beautiful smells. You can think of those as biosignature gases. The mold in your fridge, or if you have a compost and it smells so bad, those are biosignature gases as well. And so this image is showing you that there are thousands of molecules, but only as stars, than small planets translating big stars, which have a much weaker signal. I spent time telling you about the TESS mission. The TESS legacy is a catalog of exoplanets, will be a catalog for exoplanets for follow-up with next generation telescopes. And I also told you about some interesting planets TESS is finding in its own right. Astronomers know how to find planets, we're good at that now, and we will spend the next generations searching for signs of life on planets by way of atmosphere biosignature gases. Now, one thing I forgot to transiting planets are in fact quite rare, because the planet-star system has to be very specially aligned. But there are all kinds of planets out there. The new generation of telescopes will be able to find planets that are not transiting, and so the future is really tremendous for us in exoplanets. I just wanted to close with a couple more things. One is you can pause on this slide if you want to know more about TESS. There's a lot of resources out there for you to stay up to date with the latest discoveries. And finally, I wanted to convey to you this sentiment I have that I hope that you all might share with me. And that is that, someday we'd like to be able to go to a dark sky. With our out there, the star you're looking at surely has a planetary system. When I do that, I love to imagine that there's a planet around there with life, looking back at our sun, a star for them, wondering the same thing. Thank you very much.
Hello, my name is David J. Lockett. I'm a 2020-21 Albert Einstein Fellow sponsored by the NASA Office of STEM Engagement.
Oh, and so I don't know about you out there, but I imagine some of you also miss Pluto as a planet. If so, leave us a comment. But for me, Pluto just has all this mystery associated with it. And if I had a vote, I would say bring Pluto back to full planet status. How about you, Jeff?
I really like your conviction on this, Diane. I think it's sort of unfair to those of us who have grown up being science enthusiasts. That 9 planets, a marvelous gift to communicate the information, and the passion from this speaker, it just pours out. It's irresistible. And I'm talking, of course, about Dr. Alan Stern, who is the lead on the New Horizons, the spectacularly successful Pluto New Horizons mission. It really has been one of the highlights of science in recent years. So I think I'm
going to start my little timer, and there's no place to put the timer, so we'll just figure it out as we go. Okay, so I thought I would start at the very beginning of this story, but it's a little risky, so bear with me. Yeah, that's me. When I was a little kid, I wanted to grow up and be a scientist. And all my parents, all I ever wanted was books on astronomy and books on dinosaurs and microscopes and telescopes and all those things. And I gave you that are thinking about careers in science. It's not just about research papers and computer modeling and, in my case, going to telescopes. I got to do some really interesting things. As Tony described, I ran the NASA science program for a few years. I've done expeditions to the South Pole. This is a picture of me back in my flying days when I flew F-18 Hornets for NASA for 5 years doing airborne astronomy missions, and I flew other types of aircraft as well. But absolutely my favorite part of my career has been space missions. And I've been involved in 29 of them now, of which my very favorite is Project. In the 1960s and 70s and 80s, in our parents' generation of explorers, the very best, most prized missions were always the first missions to a new planet. First mission to Mars, first mission to Venus, Jupiter, Saturn, what have you. And by the time I got to tell you in the next 35 or 40 minutes, This is a pretty good picture of Pluto. Let me show you what it was before we went there. Oh, that's the book. We already talked about that. That's the best picture of Pluto ever made before New Horizons arrived. How's that for, right? Planetary science. It's a picture of the Earth. And if we'd never been to the Earth and you only had this one picture, you could learn a tremendous amount. You would learn it's a water ocean world with punch. It's not so good. My postdoc Amanda Zangari did that just to illustrate the point. There's the Earth at Pluto resolution. What can you learn? Right? It drives home the point that we have to go to these places, even though it's expensive and far away and takes a lot of time and a lot of effort. We have to go there to really learn about them. What is this a picture of? Similar resolution. One guess. Who's got a guess? Mars. Excellent guess. And completely wrong. Right? Right? Same thing. I just pixelated this image of the American flag. So you can go way wrong. So we want to go to the planets. We've been doing that since the 1960s, since the earliest days of space exploration. And I thought I'd talk to you a little bit about how we got to do New Horizons. Because between the early 1960s and the late 1980s, the right people that were decision makers didn't have the right design, didn't have the right cost controls and management, whatever. And each time we had to change. Almost 100 years ago in 1930, Pluto was just the tip of the iceberg. And by the time the telescopes got good enough, and CCD at the back of those telescopes in the 90s, we started to discover that there are planets like Pluto dotting the outer solar system beyond Neptune. So Pluto wasn't an oddball, kind of a misfit that didn't fit the pattern of the inner rocky planets and then the giant planets. Pluto was the harbinger of a whole new class of planet called the dwarf planet teams, and compete to design and build and fly this mission across the solar system. By then, in 2001, we'd been working on this for a dozen years. And it was finally time to actually go and do it. And so my phone rang from the Jet Propulsion Laboratory in California, and they had led every first mission to the planets in history. And they said, would you be in charge of our mission to Pluto? Felt pretty good about that. And then their Arch was one of those teams, and fortunately, we won. We won that competition. And then, it's that old saying, oh, we got what we wanted. We got what we asked for, now what do we do? Because we were in a horse race to get this built. And the reason was, by the time the competition was finished in 2001, one 3-week-long window in time in January of 2006. Launch it then or go home for a decade. So, and that was only a little over 4 years after we were selected in November of 2001 to do this. So we were really under the gun. A typical mission, like you've heard of Voyager, and maybe you've heard of the Mariners and other historic first missions, they typically would take 6 to 10 years to design and build and test it and get it ready and go. And we had 4 years and 2 months. And so I call this whole period the blur. From 2002 to 2005, the 2,500 men and women. So every one of those people was a leader of some team, the launch team, the mission operations team, the engineering team, so forth and so on, myself included, for the entire mission. And this is a group of Americans who worked incredibly hard under very difficult circumstances. Besides having to do this in half the time, the budget that NASA had available was only 1/5 the budget that NASA had to do Voyager. So we had to reinvent how to use gold foil, which is a thermal blanket, because where we're going is very far from the sun, too far from the sun to use solar rays. The temperatures are almost absolute zero. They are literally 40 degrees above absolute zero, far out there. The spacecraft is powered by a nuclear power supply. I'll show you a picture of it in a few minutes. It communicates through this dish antenna with a small transmitter, only 30 watts. And inside this box is propulsion and guidance, communication systems, thermal control, main computers, and ever in the 1930s and named for the planet Pluto. So we actually launched plutonium to Pluto. And that's what powers the spacecraft. Now think about this. That nuclear power supply only produces about 250 watts of electricity. It's about 4 light bulbs. So every It is 225 feet tall. These solid rocket boosters alone are 7 stories tall. There's 5 of them on this. This is the most powerful rocket that existed back then in 2006. And when I was a little kid, I used to build Estes model rockets and launch them, sometimes down the street at police cars, but usually straight up. And I have to tell you, for a kid that mowed lawns and washed cars to get nose cone, all the goodies, is a $180 million rocket. That payload bay, the bulbous part at the top, the nose cone, is built to fly satellites the size of moving vans. And we put little New Horizons in it on the top. It was like basically the hood ornament on the rocket was our spacecraft, right? That was the other thing. How many of you built model rockets? Ever, right? I don't know if you're like me. I could never get the sticker on straight without a crease. Look at this, NASA, perfect. Okay, so that's New Horizons inside the nose cone. That's me standing in front of it on the day that we fueled, just 6 days later. And I thought I'd show you a video of the launch and just stop talking and let you watch the launch. Remember as you watch this that the rocket, it's not 5 or 6 feet tall like you see projected here. It's 225 feet tall. Watch it when it lifts off. It's a downtown skyscraper that takes off vertically. You'll see it cross a cloud deck about 10 seconds after launch. That cloud deck is 2 miles high. Think New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Just 15 seconds. Everything continues to look good. Perfect. As the Atlas V vehicle climbs away from Florida's east coast, the 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system. Six minutes later, it was in Earth orbit, going 18,000 miles an hour. We flew halfway around the Earth to the point that had been mathematically calculated to aim for Jupiter, and relit the engines, took ourselves out of Earth orbit, burned out the 2nd stage, lit the 3rd stage, and accelerated the spacecraft to become the design and build a spacecraft. But once we launched it, all we needed was a small flight control team, the science team, and a very small engineering team. So one thing I didn't tell you about, but I want to, is that in order to make all of the images and spectra and other data types that we had to collect work out when we got to Pluto, we had to arrive very precisely after this long journey of 9.5 years. In fact, in order to know where everything, we programmed the spacecraft, and we had to tell it when it would be there and exactly where it would go through the system so that it would know where to look to photograph Pluto and each of its moons and do all of its work, over 400 scientific observations. And so it was counting on our arriving at just the right place and time. In fact, the window in space that we had to arrive at is about the size of the time that we set when we launched. Yesterday, I flew from Denver to Des Moines, and United Airlines could not pull that trick off. Not even close, okay? We actually arrived at Pluto only 86 seconds off target after 9.5 years. I'm pretty proud of the fact that we arrived early, by the way. This is a kind of a family portrait taken from millions of miles away on approach of Pluto. And for reference, because you're not familiar with this, the distance from one side to the other is about the distance from Denver, Colorado, where I live, all the way to New York City. Of interesting geology. Sharon's kind of dull and dark and gray. And I'm going to spend most of my time telling you about Pluto rather than the moons. This is a set of images that we took from New Horizons as we flew by, and then we put them in a computer and wrapped them on a sphere to give you the impression of what it would look like to actually be there. And you can see lots of other interesting geology. These are big tectonic canyons, probably formed by the stress of the impact that made this basin billions of years ago when something 100 miles across hit Pluto and dug this basin out. But you can also see lots of craters. I'll show you more about that. And you see all these craters? In my field, in planetary science, we use this to age date the surface. And the experiment's pretty simple in principle. It's easy to understand, even though the math is intense. But if it was raining outside and you ran outside with a sheet of paper, it would start to dot. On the glacier, what do you see? How many craters? How many craters do you see? None. Not one. Everywhere we look, even with better images than this projector can show you, we can't find a single crater anywhere on this surface the size of Texas and Oklahoma, which means this surface is young. In fact, we can calculate an age for it. It's 1,000 times younger than the terrain right next to it. It's millions of years old at most. I say at most because we don't see any craters. All we can do is set a constraint on its age. But what this means is that little planet Pluto is somehow creating terrains 4.5 billion years after it was formed, these volcanoes. And this structure is large. It's about the size of Mauna Loa in Hawaii. It's 15,000 feet high. The caldera, the hole in the middle, we can see down into it, and we have stereo imaging, so we know exactly how deep it is. It's 10,000 feet deep. The entire structure is about 100 miles across. And if you look on the flanks of this volcano, you can't find any craters there either. We think we may have found one. But again, this must have been created recently. All this activity is going on in this little world that we thought should be a dead world. Here, we see the solar system. The smaller the world, the simpler it is. Pluto is totally opposite. And so I thought I'd show you this and a couple of other things to say. Back in 2015, when we did this, we didn't have to imagine it anymore. No more fuzzy dot. This is a live picture taken of our science team when the very first image, okay? And people are just going nuts. They just came out of the woodwork. And it was everywhere. It was on the cover of the New York Times. It was on the cover of hundreds of newspapers the next morning, all across the world. And I got copies of newspapers from NASA, from Europe and from South America and from Asia, and we were just like, wow, the interest in this is unbelievable. I gave a public talk in Calgary, Canada, about a month later, and I said there were newspapers from every continent on the Earth except Antarctica. And the next morning, the editor of the only paper in Antarctica emailed me with the cover picture saying, us too. Go 2015. And in fact, just a year ago, in January of 2019, we had a flyby of the first ever flyby of a Kuiper Belt object. And these are very different from planets. These are the building blocks of planets. They're tiny, and if the AV guys can start this video, it runs very quick. Here's Pluto, and we're going to zoom up on the 4 billion year old building block of planets like Pluto, and the planets of the inner solar system too. You can see it looks like two things that are stuck together. That's called a contact binary because the objects are contacted, not orbiting each other. Very strange world. This is in true color. It's very red. Its surface is covered, unlike any of the worlds of the inner solar system, about how these so-called planetesimals, the building blocks of planets, formed. And it's totally revolutionized our knowledge of how things formed, of how the planets got their start. And I can tell you, for those of us, I showed you that picture when we flew by Pluto. This is 4 years later in 2019. For the people who worked on this is 3 in the morning on January 1st, right after it turned 2019. And the skeet shooting was perfect. Now we're going even farther out. The spacecraft is still traveling at this amazing speed. It's got fuel and power to run for another 20 years. And we are journeying farther into the Kuiper Belt and looking for our next flyby target. And I will end by showing you my favorite picture of the entire mission. This is a picture of Pluto, taken just after we flew past it, and we're looking back. This is true color. This is Pluto's atmosphere, which is actually blue, just like the Earth's sky. And it's back, and then it flies all the way across the solar system, and nothing breaks. And the flybys work out perfectly, and the science is mouth-watering. For me, this is like the Apollo images of the Earth rising over the moon. That we did it. Because the only way to get this picture is to be on the far side of Pluto. And our team really did that. And we're so proud of it, and we're so thankful that we live in a country that can do these great things and that can go down in history for being a country that actually cares about science and engineering and about contributing to the world in a positive way. Thank you very much.